current. The current is created by turning a high-strength permanent magnet on the rotor, in close proximity to the magnetocoil. The coil contains two windings, a primary winding and a secondary winding. The primary winding's purpose is to capture the magnetic lines of flux created by turning the magnet. The current from the primary winding flows to both the breaker points and the capacitor, which are wired in parallel. When the breaker points are closed, the primary winding is grounded and the current flows directly into the case. When the breaker points open, the field in the primary coil collapses. The collapsing magnetic lines of flux cut across into the secondary coil. The secondary coil has a far greater number of turns, meaning that the induced current is of much higher voltage. The current is then routed to a distributor where it crosses a small air gap, travels down a lead, and creates spark inside the combustion chamber. There are many parts inside of an aircraft magneto, and I will now take the time to explain a few of the critical components. The magneto case is separated in two halves, the magneto housing and the distributor housing. The magneto housing is the larger half and contains the coil, while the distributor housing is the smaller half and contains the distributor block along with the points and capacitor. The points cover is a small cover that protects the points, capacitor, and cam from FOD. The oil seal is pressed into the magneto housing and the rotor passes through it to connect to the engine drive. The oil seal's primary purpose is to prevent engine oil from entering the magneto housing. The points in the system open and close the path to ground from the primary coil. This causes the primary coil to charge when the points are open and discharge when the points are closed. The rotor is the largest component of the magneto. The rotor is divided into several sections. The drive end of the rotor is threaded and made to accept an impulse coupling. The impulse coupling is locked into place using a Woodruff key and a castellated nut. The next section is the large ball bearing. The inner race is pressed onto the rotor. The outer race is pressed into the magneto housing. Next is the magnet, which when turned provides the magnetic field necessary for operation. The gear on the rotor's purpose is to drive the distributor gear. The smaller ball bearing's inner race is also pressed onto the rotor, and the outer race is pressed into the distributor housing. The final section is the cam, which I will explain later. The points are actuated by the cam, which is located at the end of the rotor. As the cam turns, the high spot pushes up against the cam follower, which in turn opens the points and disconnects the primary circuit's path to ground. The coil in the system is used as a step-up transformer as well as part of the AC generator by picking up the magnetic lines of flux created by the rotating magnet. The capacitor's only job is to prevent the current from the primary winding from jumping across the breaker points to ground. The distributor block is the connection between the magneto and the leads. The distributor block has a center boss in which the distributor shaft rides. The distributor block also has electrical contacts. High-tension